direct variation can be modeled by the equation y is equal to kx, and inverse variation can be modeled by the equation y is equal to k over x. What I'd like to call attention to in direct variation is that x and y increase or decrease together. In other words, let's pretend the value of k is 5. If you substitute a large number like 1,000,000 in for x and multiply it by a 5, you get 5,000,000 coming out. X is large, y is large. Similarly, if you substitute in a tiny number like 1,000,000,000th and multiply by 5, you get 5,000,000,000ths, which is very tiny. Tiny number in, tiny number out. Whereas for inverse variation, as x increases, y decreases, and vice versa. Let's again pretend y or k is equal to 5 and substitute a number like 1,000,000,000 in for x. Dividing, you get 5,000,000,000ths for y. With a huge input for x, you have a tiny output for y. And if you have a tiny input like 1,000,000,000th, when you divide by that fraction and then multiply by 5, you get 5,000,000,000 coming out. Tiny input, large output. So x and y are having an opposite sort of relationship here. Now k has a couple of different names. It's called either the constant of variation, or it's called the constant of proportionality. And it just depends upon who you're talking with in terms of which vocabulary they choose to use. Let's begin by setting up some models. Whenever you see the word varies, it can be replaced with equals k, just like an equal sign or is the same as can be replaced with an equal sign. We're going to write w, and instead of varies, we're going to write equals k, and directly as capital Z puts a capital Z on the right. So we're not using y and x like I described above, but we have different variables. M varies. M equals k. Inversely tells me we're going to have a fraction and that the t is going to be down in the denominator. In the third problem, w varies. Now jointly tells us we've got two variables or more variables coming after that, so p and f are going to be up there with the k. You'd need a inversely word there to put either of them in the denominator. Joint variation is assumed to be direct variation unless you are told otherwise. Now we're being asked to find the constant of variation. We're told that m varies directly as x, so we can write that down, and we're told that x is 8 when m is 22. So we can substitute those values in and then be able to solve for k, which in this case is going to be 22 over 8, which will reduce to 11 over 4. In this next problem, t is inversely proportional. That tells me we're going to have a fractional here, inversely proportional to x, and when x is 40, t is 200. So 200 is equal to k over 40, and multiplying each side by 40 tells us that 8,000 is going to be the constant of variation. Now let's take these problems to the next level where we actually use the equation we create to solve for something. M varies directly, there's equals k, as the square of x, so there's x squared. It tells us if m is 200 when x is 20, find m when x is 32. Well, let's just start with the first half of that sentence. That gives us 200 is equal to 400k, and therefore k is equal to 1/2. Now let's substitute that 1/2 back into the equation here. What we write then, m is equal to 1/2 x squared, is sometimes called the general equation of variation for this problem. Find m when x is 32 tells us to now substitute 32 into that equation. m is equal to 1/2 of 1024, and the value we're searching for is going to be 512. Let's try this again, but this time they're not giving us variables. The number of turkeys needed for Thanksgiving dinner is directly proportional to the number of guests. Well, let's focus on the key nouns in this sentence. Turkeys, guests. Turkeys directly guessed. T for turkeys equals K times G for guests. Notice how I'm getting rid of the extra verbiage in that sentence as I write that out. If a cook knows that it takes 3 turkeys to feed 42 guests, well, 3 is equal to K times 42, and dividing through by 42, we find that K will equal 1/14. The interpretation of this is that each turkey will feed 14 people, or that one guest will have 1/14 of a turkey. I can rewrite a general equation here of T is equal to 1/14 G. How many turkeys should be used or cooked for 70 guests? Well, substitute in 70 for G, multiply by the 1/14, and find out that we will need 5 turkeys.